Okay, game on. No daily check because kind of in that weird spot again between sections. Assignments, hopefully we're keeping up with those. Tomorrow, assuming nothing really weird happens to change it, tomorrow you're all going to be on video duty and I'm out. Okay, I got stuff to take care of. Okay, you will do the entirety of 4-5. It's normally a day and a half, but I know that y'all usually run through it faster when you have the video to go at your pace. Okay? So it'll be the entirety of 4-5. It'll be a video and a half queued up from last spring. Okay? But there'll be no daily check, no homework questions, nothing like that at the beginning, so hopefully it'll be a little quicker. Yeah, hopefully that'll catch us up a day so that we can do 4-6, 4-7 and not lose too much time. I was already planning that we'd probably need one extra day. Right now we're at like a day and a half extra, so I'm hoping this will catch us up. Okay? So tomorrow, probably have a sub. I don't know who it is. The gal that was here last Wednesday when I was out sick, most of you were out testing. I will hopefully have her off and on for the next couple weeks because I just got stuff to do, and she was solid. She was solid. I liked her. So I had positive reports across the board. So I wasn't able to get her for tomorrow, so tomorrow's just going to be a warm body and watching videos. Okay? Reminder that you can always ask questions. Ask questions on Remind. Pause the video. Ask the question. Well, see if I answer the question later because someone asked it before. Ask the question. Okay? So, today, just review and quiz. Get her done. And we've been kind of in the thick of 4-4. Normally it's like a 2-day thing. I think that took us 3.5. Again, we're seeing those gaps in geometry knowledge coming back to bite us as we're doing stuff with radians. We're talking about rotations, revolutions, and whatnot. And we've been mired in it. So most of this test is based on, do you know sine and cosine functions? Okay, one of the few things that we didn't do on just 4-4 was, if I give you this information, can you tell me what quadrant it's in? Can you sketch the angle in the correct quadrant? Tell me its reference angle, find the missing side, and then go get all the trig functions. All of the above. So to start with, if I tell you the tangent is 8/3, how do you find the reference angle? Like completely ignoring this, because remember, reference angles are always positive acute angles. If the tangent is this, how do I find the angle? Not needed. Now I'll sketch it, but how do I just find an angle if I know the opposite and the adjacent? Get that calculator and do arctangent. Okay? Do you want your angle to come out in radians or degrees? You get a choice. Do you want to say something, point, blah, 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 terms of pi radians? Or do you want to say something degrees? Most of us are probably going to want degrees. So, get your calculatron. Oh, my calculatron's over there. And I'll say the arctangent of 8/3. Okay? Arctangent of 8/3. About how much? In degrees. Please tell me it isn't. All right. 69 point what? Are you in degrees or radians? Okay, so if that is in radians, you would need to convert yours in terms of pi. So now you need to take that divided by pi so you can write it in terms of pi. Right? You can do this in radians. You will get ugly decimal. You just divide that by pi and you say that much pi. The directions say, tell me the reference angle. Maybe it would have been better to just draw the triangle to begin with. Okay? What quadrant is this triangle going to be in if tangent is a positive 8/3 and cosecant is less than 0? It is 3. Remember, this is a positive tangent, and if cosecant is less than 0, cosecant is negative. If cosecant is negative, who else is negative? Sine. And then, whatever acronym your choice is, all students take calculus. Where is tangent positive but sine negative? Third quadrant. So I'll sketch my triangle down here. It doesn't have to be to scale, just draw a triangle. All right, tangent is 8/3. What number goes where? Opposite and adjacent, but because I'm in this quadrant, negative, negative. That's why I still have a positive tangent value, because negative over negative cancels. Now, here was theta prime. That's what I just found here, my reference angle. So I got my reference angle. I sketched my triangle. I have it in the correct quadrant. I've got 2 of the sides placed. Go find contestant number 3. How? Good old Pythagorean theorem. Our royal Greek cult leader. Okay, we're going to do the square root of negative 8 squared plus negative 3 squared. 64 plus 9 is 73. Square root of 73, as far as I know, can't be reduced. So, it's just square root of 73. Positive or negative? How do I know? Hypotenuse is the radius. Radius is always distance from 0, so it's always positive. Additionally, when I square those negatives, I end up with positive values inside. Now, technically, you have a plus or a minus radical, but we ignore the negative part of it because this is distance. Distance can't be negative. These negatives just indicate direction. All right, so I have my reference angle. I have it sketched. I have my sides. What else do the directions want? Go find all those ratios. Can you do it without the signs up in the room? Sine, cosine, they're in a pile right there. The tangent, the cosecant, secant, and cotangent. We know that tangent was 8/3. So cotangent is just 3/8. That's nice and easy. But now that I have my angle here, I can go find the rest of it. Sine, opposite over hypotenuse, make sure you rationalize. Negative 8 root of 73 over 73. In this case, the 8 and the 73, both outside of radical land, they don't reduce. What if that was 8 and 72? Okay. Double check to make sure. If something can reduce once it's outside of radical land, once you rationalize, double check to make sure that's possible. Okay, its reciprocal, a little bit easier, negative root of 73 over 8. When we switch over to cosine and cosecant, or cosine and secant, same business, it's just a 3. Negative 3 root of 73 over 73. Negative root of 73 over 3. I forget which class it was. Someone was a little confuzzled about the negatives on there. Remember that it's considered kind of improper to leave the negative on the denominator. We either put it up on the numerator or out front. It's safest to just put it out front because then you can apply it to whichever one you feel like. Okay? I tend to just get lazy and write it whenever I think of it. So, notice this test has only 5 questions this time. That means each one is worth 6 points. Did you find it? Are you in the right quadrant? Did you find the value? Did you find all of these values? Did you find all of those values correctly? And then I'm double checking signs. Signs and simplification. Okay? All right, on to the graphing. We have spent 4 days, 3.5 days, pounding the snot out of these. I think we're good by now. Start by writing out all of your information. Notice the directions don't say, tell me all the stuff, because you need to have the correct information to get the correct graph. So we begin with midline. I'll say my vertical shift is negative 4. So, negative 4 goes in the middle. I've got an amplitude of 9. So we go north and south of that guy, 9 units, all the way up to 5, and all the way down to negative 13. You know, if I move those all the way up here, is that okay? All right. That just means that each of those boxes is 9/2 now instead of 9, right? I still have my amplitude shown. I'm going to move them out there just so I can write all of my numbers on the axis and it doesn't look as cluttered because my graph will be a little bit bigger. Yeah? Absolutely. I'm actually going to do that at the end of this. So, my baloney has a first name. Here's phase shift. Phase shift is negative C over B is a positive 12 pi over 8 or 3 pi over 2. So we'd start with 3 pi over 2 here and period. Period is 2 pi over B. B is 8. So period is pi over 4. Now, if I add pi over 4 to this, what's that? 6 pi over 4, 7 pi over 4? 6 pi over 4 minus pi over 4 is 5 pi over 4? I am just adding the pi over 4 onto that now because I'm still in blue. All I did was add pi over 4 to that. I haven't done the quarter marks yet. Yeah. Pi over 4. When you reduce it. And 3 pi over 2 would be 6 pi over 4. 6 pi over 4 plus 1 pi over 4 is 7 pi over 4. I'm only doing it in this order because I'm still in blue. It was to save time, but it actually ended up costing us time because we were freaking out about quarter marks. Because then I would want to find my quarter marks because that's where all of these boxes are labeled as my relevant features. If the period is pi over 4 wide, that means the relevant features of it are going to happen at pi over 16 increments. Make sure you reduce along the way, because this guy at 3 pi over 2 would now have to be written as times 8 times 8, 24 pi over 16, and then I'll keep adding iterations of 1 pi over 16. I have to reduce them along the way. So, 24 pi over 16, 25 pi over 16. 26 pi over 16, reduce it. 27 pi over 16. And coming full circle, 28 pi over 16, reduce it. Okay? If this is at 24 pi over 16 and I keep reducing from there, 23 pi over 16. 22 pi over 16, reduce it. 21 pi over 16. 20 pi over 16, reduce it. Do we remember cheater shortcut to doing this without having to get that mental math on? Okay, over in your calculatron, I took my phase shift and I kept adding multiples of my quarter marks. So multiples of, all the way back to section 1.1 when we're doing set builder notation, can be written as in terms of integers. So if I say y sub 1 is my phase shift plus quarter marks x without the pi. Don't put the pi there, or it just gives you a whole bunch of decimals. Okay? So if I would put negative 3/2 plus 1/16 x, go to my table, all those integer values are going to be these fractions. What? No, I said 3/2. I might have. I was up 4 times last night. Yeah, but all of your values are going to be inverted. What you see at x is -1 is actually what you're going to put 1 unit to the right. Yeah. That's just a calculator shortcut if you don't want a fraction. No, I'm saying don't put it with pi. Skip the pi. And then just write the pi's on your paper. Okay? Here. No pi for you. Come on, Frank. Yeah, the phase shift was 3 pi over 2. So put 3/2 plus, my quarter marks were pi over 16, put 1/16 x. It's going to keep adding multiples of 1/16 to 3/2. I don't want to put pi in there Because if I did, I wouldn't have any of these fractions. It would write them all as decimals because these calculators don't write in terms of pi. Didn't I get 5 pi over 4, 21 pi over 16? Phase shift. Okay? Like this just gives you those fractions if you don't want to fraction. I'm trying to save you time, but it sounds like it's taking more time.
That's what I'm getting from it. Okay.
That's why I said the same thing the whole way down, because you were just doing the same thing for every one of them. It happens. Okay. And then, finally, we get to the sine value itself, or the sine graph. Sine normally starts at maximum, midline, or minimum? Middle. Whoop. So then we do our dance, up, middle, down, middle. Now before I do that, because some of you want this, if you want to put your stuff like off to the side, if you want to put your stuff off to the side like this, and screw you, I'm going to write on you. You know, be that way. I'm tired. You're just going to get written on. Deal with it. Well, oh, wait, it got whoop. Just like Agent Smithed its way out of the line of fire. Yep.
I know it's the Matrix. I know it's the Matrix. He's lying. I know it's the Matrix.
You best be bringing food, bud. Okay. So again, if you want to label these off to the side or you want to label them on the graph, I don't care. I tried to make the graphs big enough that you can do both. Okay? Whatever your jam is. Now, one of these problems is going to have integers. One of these problems is going to have fractions. One of them is going to be sine, one of them is going to be cosine, and I literally used a random number generator of values, negative 12 to 12, to write the problems. So, what you're going to get. So, same thing. Try to go a little faster this time. We have amplitude of 1/5. We've got a vertical shift of 1. I put 1 in the middle. I go 1/5 north and south of that. So here's 1 and 1/5, or 6/5. Here's 4/5. My phase shift. Phase shift is negative c over b. C is 3 pi over 2 over a 1/3. Be careful with those. I still see kids make that mistake on quizzes. That is not over 3, it's over 1/3. Flip the second and multiply. My phase shift is negative 9 pi over 2. You know, you can just ask me to go slower, louder, instead of, no, it's not. If I need to go slower, you tell me to go slower.
You're actually throwing so hard.
Does the negative who?
For the negative 1/5.
Oh, that just means the direction that my graph is going to go. I don't need to do anything to the amplitude for that. Okay. Period. 2 pi over 1/3 is 6 pi. Dang. So add 12 pi's to that is 3 pi over 2. Add 12 pi over 2, subtract 12 pi over 2 is negative 21 pi over 2. Quarter marks. If I take 6 pi times 1/4, ironical, 3 pi over 2. Because now it turns out when I had fractions in the problem, the horizontal axis ends up being not that bad. Correct. But 6 pi I need to turn into 12 pi over 2 to have common denominators. Don't do the period thing first. Just count by quarter marks. Okay? It's easier. If I'm at negative 9 pi over 2 and I add 3 pi over 2, I'm at negative 6 pi over 2 or negative 3 pi. If I add 3 pi over 2 to negative 6 pi over 2, I get negative 3 pi over 2. If I add 3 pi over 2 to negative 3 pi over 2, I get 0. I get negative 12 pi over 2, reduce it. Negative 15 pi over 2. Negative 18 pi over 2. Negative 21 pi over 2. What are you up to now? 5, 6? Okay. And then cosine normally starts at maximum, midline, or minimum. Normally starts at maximum. Now the negative comes into play, so I'll start at the minimum. And then do the dance. Middle up, middle down. Middle up, middle down. And again, you can have these values off to the side. You can have them right smack in the middle. You can have these values downtown. You can have them right smack in the middle. Okay? It's your choice. I take both. I'll tell you, just so I can see the numbers more clearly, my answer keys, I actually have them off to the sides. Okay? All right, so we did sine graphs, we did cosine graphs, and then we started talking about how do I actually make these things? Do I understand what the various features of them are? Remember, we are always going to use cosine. My amplitude will be found with maximum minus minimum over 2. Or I could do maximum minus d, d minus minimum. Okay, maximum minus d, midline, or d, midline, minus minimum. So you got 3 different ways that you could find A. 2 of them depend on being able to find your midline. Your midline is the midpoint between maximum and minimum. So add them up, divide by 2. Okay, the stuff we were doing yesterday. The period. Well, we don't just straight up put the period into our function, but we do have b, which is part of the period. Period is still 2 pi over b. but the period is going to come from the context of the problem. You have to ask yourself, when will this cycle repeat itself? And it all depends on the problem itself, like the one that I assigned with last night had the tides. How long does it take to repeat itself? Okay, theoretically that would be 24 hours. Maybe it was a little bit different based on moon's rotation. Some things might be in days, some might be in years, some might be in months. It depends on the context of the problem. Once I have B, I can go find my phase shift, because phase shift is negative C over B, and the phase shift is when the maximum occurs. That's why we're using cosine. Because if I normally start at my maximum, my shift is how far did I shift over to the maximum. So we got all of that. Here we go. Y is cosine of x plus. The attendance of a museum is shown below. Determine the exact sinusoidal function in terms of pi. Notice it says exact sinusoidal function. That way, if you try to jam this into a calculator and do sine regression, you ain't getting the right answer. Use x equals 1 represents January. Assume the museum is open year-round, but all data relative to the function is shown. I had to put that on here specifically because in previous years, kids would say the period is 8. They'd say it's 8 months. Because they would think, well, 8, start over. Like, y'all, where did September, October, November, and December go? Okay. So, that's why it says assume it's open year-round. Hey, they just told us it's open year-round. So, 12 months for the cycle to repeat itself. A lot like tourist season. Tourist season is going to theoretically happen, peak, every year. So, we go find the period by saying 12 months is equal to 2 pi over b. Cross multiply solve and get b is pi over 6. I heard a wait, so I'm waiting. Are we? So, phase shift. When does the maximum attendance occur? July. So if the maximum attendance occurs here, and they said January corresponds to x equals 1, well, looks like I have a phase shift of 7 months over. So I'll say 7 is negative C over, and I just found out B was pi over 6. So, cross multiply solve and get C is negative 7 pi over 6. What else do we need here? We need our amplitude, maximum minus minimum. Go find the minimum. We got the maximum already. 8. They average 8 visitors per day. Hoppin' business. Okay. It depends what kind of museum. Like, the town I went to high school in, they had a museum. It was only open one day every other week, but it was a museum. Okay? So, I will take 32 minus 8, 24, divide by 2, amplitude of 12. The midline, halfway in between 8 and 32. Halfway in between 8 and 32 is my midline, because those are maximum minimum. So I add them up, divide by 2, and get 20. Whoop. You don't even have to use it to answer any other questions. Well, we don't here. I don't remember what's on your test. Ta-da! So what I'm looking for here is, again, those 6 parts. You got it, you got it, you got it, you got it. Did you actually use cosine? And then probably 1 for floating in there, making sure that you didn't do just oops math. Okay? Who? Well, I just erased part of it, but minimum plus maximum, divide by 2. 32 plus 8 is 40. 40 divided by 2. There you go. I want you to stop me. I want you to interrupt me. And then, y'all have, in 28 days, you got your final. 28 calendar days. You have your final. It is coming. It is coming. So, yeah, you're going to start seeing more of this review stuff. Do you remember? Make the polynomial that has these roots. Option 1. By definition, the way that you were taught in Algebra 2, I'd say x minus negative 2 plus 4i. If this is a 0, then this is the factor that created it. Hey, this particular 0 has an I in it. I is a square root, therefore it must have a conjugate buddy. So it also has x minus negative 2 minus 4i. Nope. I remember there's a shortcut. Show me the shortcut. Okay. X minus 1 minus 3 root of 2. X minus 1 plus 3 root of 2. You'd have to distribute those negatives. You'd have trinomial expressions. And then just go distribution bonkers on it. But if you did, the same things would cancel every time because they're conjugates. So I could have instead written x squared minus 2ax plus a squared plus b squared if I see an I. If I don't see an I, x squared minus 2ax plus a squared minus b squared. Again, nearly every Algebra 2 teacher I've ever talked to has just come up with this on their own and said, oh, hey, this works every time, and then showed their students. But I've never seen it in a textbook. Ever. Okay? So, x squared minus 2ax plus a squared plus b squared times x squared minus 2ax plus a squared minus b squared Wait. Correct. Be very careful. Number one error on this is goofing the plus or minus on the a squared and b squared. The number two error is putting I in with b. Remember, b is the coefficient of I. A -2 goes here and here. A plain old 4 goes here, not 4i. A 1 goes here and here. A -3√2 goes here. Getting x squared plus 4x, 4 plus 16 is 20. X squared minus 2x. How do I square -3√2? Square both parts, outside and inside, then multiply those together. 3 squared is 9. Square root of 2 squared is 2. 9 by 2 is 18. So 1 minus 18 is -17. Now you still have to do that, but that cheater eliminated 2 whole sets of trinomial distribution. And we went through different methods of multiplying these. Do you want to spaghetti monster all those arrows? Do you want to make up your own acronym for an example of FOIL? It's just now it's 3 terms. Do you want to do box method? Do you want to stack them together, old school multiplication? Whatever your jam is. Okay? There's a lot of kids who say they don't want to do box method, usually because they have some sort of like horrible flashbacks from biology. Like that. But then they try the box method in multiplication in math, and they're like, wait, this is actually really organized and neat. This is easier. So you do you. All right. If I take x squared times the stuff, I get x squared. X to the fourth minus 2x to the third minus 17x squared. Then I switch over to 4x times the stuff, getting 4x cubed minus 8x squared minus, what's that, 3468 x. Take 20 times the stuff, getting 20x squared minus 40x minus 340. Combine like terms. Three. Check me. Confused where? Okay.
So you just add all these numbers up, right?
Yeah, because they're like terms. Your like terms are always going to be on the diagonals if you do box method. Yes, it's called the lowest degree because if I have these two zeros and their conjugates, the minimum I can get is a degree 4. Could I have repeated some of these zeros? Ruh-roh. So if I have these two zeros, what happens if that happened 3 times? That means its conjugate happened 3 times. And then those 2 over there, so now I'm at degree 8. Okay, that's why we say find the lowest degree polynomial. Okay? Still plenty of time, like 45 minutes worth, to do 5 problems. I know some of them are thick with some extra C's, but you got the time. Okay? Devices away, scramble yourselves up, spread out.